All right, so we're going to continue with JDBC, Java Database Connectivity API. In fact, we're going to finish up with it today by finishing the exercise that we started on Friday and then going over some best practices. Let's remind ourselves what we were doing last time. We had written code to to pull a person out of the database along with their emails, and then we wrote code to persist or save a person to a database, and then what we were going to do next was try to get their emails into the table. Remember, we are online, so if you have any questions, go ahead and post to the YouTube live stream here. But we had gotten most of the code done here, right? We made a connection here. We formulated our query. We're going to insert into the person class the first name, last name, date of birth. We set each one of those things, which is all strings, and then we insert the new record, right? And we did that by executing this update. Remember, for all CRUD, create, retrieve, update, and destroy. So for the create, which is insert, the update, which is update, and then the destroy, which is delete, all three of those are execute update. There is no execute delete. There is no execute insert, right? And then we closed our statement here. And then what we wanted to do is we wanted to insert into the email records all the addresses of this given person, right? And we needed the foreign key here, the person ID, in order to do that. Now, when we did that over here, right, with our test data, we had hard-coded these values here, 10, 20, 30, and 40. And so it was easy for us to do that because we knew exactly what those foreign keys were. But when we go over here to insert Guy Fieri, let's see, where is he? He's right here. Guy Fieri, who has foo@bar.com and bar@foo.com, right? We don't have a connection to Guy Fieri in the database yet. What happens is that when this execute gets updated, then we have that value. We don't have that value otherwise. So what we need to do is now we need to fix this statement so that the newly generated primary key of this person that we just inserted right here is returned to us so that we can use it below for the emails. Okay? I'm going to go ahead and cut and paste this and execute this later on. Okay? So to do that, what we're going to do is we're going to prepare our query a little bit differently. Right now, we're just preparing the query and saying, okay, go ahead and create this query for me, and I'll set the values later. We're going to parameterize this, or we're going to give an additional parameter over here, statement dot return generated keys. And what this function call is going to do is it's going to prepare the query just like before, but also it's going to set us up to do more work. Right? It's not going to do more work unless you tell it to, or unless it has to. So what it's going to do is it's going to insert that record, but then immediately it's going to, behind the scenes, it's going to execute another query to pull out whatever value was generated by that primary key. Okay. Then down here, what we're going to do is when we execute our update, we're actually going to return a result set. Actually, just a second. Let me go ahead and take a look at. I should have set myself up for this. Sorry. I'm going to have to look up the exact code here. I'm pretty sure it's just a result set that gets returned. And you'll be doing this in not the lab this week, but the lab next week. Yep, indeed. So what we're going to do is we're going to execute this update, and then we're going to set up a new result set. And I'm not going to call this RS because this result set actually represents something. It represents the keys. Or in this case, because I'm only inserting one element, I'm only expecting one key back. But it's still a result set, so I'll call it keys. Why would it be? Why would there might be more than one returned value in that result set? Well, that's what we did up here. If you formulated a query that inserted multiple pieces of data, obviously then these generated keys would have multiple pieces of data, right? 10, 20, 30, and 40, and you'd want all of those back. But over here, our query is just inserting one single person, and therefore we're only expecting one back. PS dot get generated keys. There we go. Right. Pretty straightforward. You want to generate return the generated keys? Well, then I'm going to go ahead and have a getter that gets the generated keys. And that's going to be stored in a result set here that we need to bring in. That's java.sql. And then I'm going to advance the result set to the first element. Right? Our keys dot next. Now remember when we used rs.next, we did so in a while loop. That's when we were loading up people or loading up their emails. I'm only going to do it once here because I'm only expecting one result back. What if it resulted in 0 results? Then there definitely would have been an error thrown up here, and we wouldn't even have gotten to this part of the code. So I'm not worried about 0 results. What about, say, 2 results or 3 results or 4 results? Then something really went wrong because my query was only inserting 1 result. If you want to be defensive and check to make sure that absolutely sure that there is 1 result, go ahead, you can write that code. But otherwise, I'll advance the result set to the first element, and then I'm going to pull out that key value. So int, what did I call it? Person ID is equal to keys.get, get integer. Right, there we go. Now, normally when we use those getters, we label the column name, person ID. But this is not actually a table that we're querying. So we don't have we may or may not have the benefit of this. I'm going to keep it safe. I'm just going to get that one single result that I expect back. Just like all the setters, it is 1 index base. So the first one is 1, 2, 3, 4, right? And so the first one here is 1. It's not 0. It's not 0 indexing. Okay? Once I've got the person ID, then I'm safe to close this. Then I can go ahead and insert it over here and insert each one of those emails. Right? Let me go ahead and system.out.println show you that in fact it is generating a new key. New key value is, and then I'll concatenate it, person ID. There we go. And now let's run this. I'll run the demo over here. Remember that we've got Guy Fieri and he's got 2 email addresses. It runs. There's the new key value, 41. Why? Because the last thing that we inserted had a key value of 40. So what's the next value? 41. Let's go ahead and select all the people joining over to the email table to make sure that we actually got that data. There's Guy Fieri twice because he has 2 emails, foo@bar.com and bar@foo.com. It works. Now, obviously, I'm only printing this out here for demonstration purposes. You probably wouldn't want to do that. And if you did, then you wouldn't want to do it in the way that I just did. We'll talk about that by the end of the day. Right? Any questions on basic JDBC? Putting stuff in, taking stuff out. Right? Otherwise, you'll be doing this in your lab for the next 2 weeks. You'll be doing it in the context of a web app that we've already built for you. The instructions, so if you're using an older version of Eclipse, even in maybe at the beginning of the semester, I don't know, then it may or may not work with the instructions. It doesn't matter because to pass the lab, all you need to do is make sure that all your JUnit tests pass. The web app that we built that you can actually visualize the data and load up all the album data in a web page, that's just gravy. That's just extra. Right? So if it works, great. But if it doesn't work, then don't bang your head against the wall trying to get it to work. We verified that the instructions work on, say, the current version of Eclipse, which is the March 2023 version. Okay. All right, then, let's go ahead and talk about best practices. Right. Oops. There we go. All right, so best practices when you're using JDBC, that is. Right. Best practices. The first best practice here is to avoid the star operator. Right? So using the star operator, that is the star, select everything, right, is okay when using MySQL Workbench. Because you're just doing debugging, right? This is debugging, development, etc. Right? But in an actual system, in a real system, you should not pull all of the data unless you are going to use it, right? So why would you not want to do this? Let's come back over here to MySQL Workbench and look at that query that I just made. Oops, everything. There we go. All right. Suppose that I used select star just like I used here in this demonstration. What data am I pulling? Right? I'm pulling the person ID, but I'm pulling it twice because I've joined it on 2 columns. Every time somebody has multiple emails, then I'm getting their first name and their last name over and over and over again. Right? There's a headshot here that we'll talk about in a second here, but it's null. I'm pulling their date of birth over and over and over again, right? I am pulling their emails even though maybe I don't want them. Right? This is why in this demonstration over here, when we loaded up the data load over here, database loader, there we go. I've separated these out into two different queries. What we did is we selected the first name, last name, date of birth from person, and then we went through another query here to select the address from the email table. Right? I did not use the star operator here. What if I had run this full query here, right? This full join query? Well, first of all, I'd be missing things because it's a regular old join. What kind of join do I want for anybody that doesn't have any emails? What keyword do I put here in order to get every record? Oh, we forgot it already. Left join, right? There we go. And now we're going to see Alan Turing here that has no email records, right? But we're pulling across the wire null values. It still takes some memory in order to represent a null value here, right? And so we're pulling multiple pieces of data. Not that big of a deal because Grace, that's only 5 characters. Who cares, right? And she's only got 2 emails, so okay, 5 characters there, 10 characters there. It starts to add up. Imagine that I pulled 1 million records, right? And each one of them has 2 or 3 emails. Now I've got about 3 million duplicate pieces of data. Now, what is the most expensive bottleneck of computing in 2023? It's not processor time, right? I've got an i9 on this machine, and over on the CFC server, they've got several really powerful processors. It's not memory. Memory is super cheap. What's the bottleneck still as of today, 2023? Network, exactly, right? What is the cheapest, fastest way to transmit a large amount of data? Put it on a bunch of hard drives, put it into a truck, and drive it across the country. Because you will be able to achieve that and then load up all the data when you get there in a fraction of the time that you could send it over the fastest internet connection that you have, right? Even today in 2023. So, back in 1970, when they wanted to shave off a few characters here and there because memory was measured in kilobytes, we're still living that life here, but with respect to network transmission and bandwidth. If you can go ahead and shave off a few bytes with respect to data where you're measuring data being transmitted over the wire in megabytes, kilobytes, or megabytes and gigabytes and terabytes, you do it, right? You don't waste bandwidth if you don't have to. In fact, Google did this a couple of years ago. They changed their logo just slightly so that their logo as an image was only a few bytes less. Right? Who cares? Big deal, right? But when you're sending that logo billions and billions of times a day, right, those bytes add up, and it matters. Why? Because it's network bottleneck. And so you don't want to use the star operator, right? You be intentional, right? Specify the columns you want, and only those columns, even if it is all of them, because it is a best practice, right? It also future-proofs you, right? Some DBA could come in and muck up with our database, right? Could change the data model, right? And our code may then be pulling data it does not use. For example, over here. So some DBA came in and said, okay, well, it's a great idea. This is a great database, but also we want to store headshots for ID purposes in our account system here. And so what they did is they came in and they added a blob, right? What is a blob? A blob is a binary large object. Now they're storing a file, basically an image.jpg, in the person table. That's their headshot, so that we can verify, okay, yeah, that looks like you. You can go ahead and pull out your money from our account system, right? If they're storing that in the person, and over here in JDBC, I was not using the actual columns, and instead I was using a star operator here. Am I actually aware that there is even a binary large object file being sent over the wire now? Nope. Because the DBA changed the data model on me without telling me, and maybe they did tell me, but now I need to change my code. But if I had written my code correctly to begin with and only pulled that data which I need, now I don't have to worry about that. Great, go ahead and make whatever changes you want. right? I don't care because I'm not pulling that data. Imagine now these are large files, right? A megabyte, 2 megabytes, depending on how much compression is in these images. It's not necessarily a JPEG. It could be a full PNG, right? And now it's like 50 megs high quality 4K image or something like that. And you're pulling out all across the wire for one record now. Now you're wasting 4 megabytes or 4 gigabytes of bandwidth or whatever. No image is 4 gigabytes, right? Except for like space images and stuff like that, right? So don't do that. Cut down on redundancies. It future-proofs you, basically. There are also security issues, right? Now, for the purposes for this course only, we are storing passwords in plain text in a Java source file, right? That's what I was doing this entire time. Let's go back over and show you. There's my password. Why am I comfortable with sharing this? I can guarantee you I do not use the password CS2 on any of my actual accounts or anything that I care about, right? I am exposing it to you. You can see it. You can do whatever you want with it. I'll change it once somebody starts screwing around with my database account, right? Because I still have that power. You will be working with a partner. Maybe you're not working with a partner, but if you are working with a partner, then they're going to be seeing that password. Even when you turn it in, one of the LAs or myself, whoever grades it, we're going to be able to see that. So you're storing this password in plain text, right? And that's bad in general. In fact, a couple of years ago, somebody proved how bad it was by simply just scraping every GitHub repo, publicly available GitHub repo, for variables called password or passwd or pass or something like that. And they scraped it and got thousands and millions of valid passwords stored in source code that somebody had neglected to take out before they made their commitment to the repo, and they reported it. Right? I think that GitHub changed their policies so that they're actually actively scraping now and warning you about this. Try to check in code that has a password in it and in a public repo, and I think that you might get a warning or at least a notification. It's something that looks like a password, right? Or a crypto key or something like that. This is unfortunately very common, right? And even places like, or companies like GitHub have put in place checks for this kind of thing. For this course, don't use a password that you care about. But in practice, how is it done, right? In practice, what you can do is you can define a passwordless data source. So the way that this works is when you fire up the server, the server initially starts, you enter the password manually. Then the database server starts, right? And it's good to go, right? Then nobody needs a password. Your application does not need a password after that first initial password entering. If the database server ever goes down or your application ever goes down, you have to fire it back up and provide another password, right? Provide the same password so that you have permission to actually start actively connecting to the database. But otherwise, after that first initial password enter, then it's fine. It's good to go. Every time that it starts up, you need to provide it again. In other words, the password doesn't exist in plain text. It exists here in your head, right? That's one way of doing it. Another way of doing it is don't use passwords at all, and you can set up a database server to, we don't care if there's a password or not. Anybody can go ahead and connect to this, but you can shut off or control access at the network level. All right, like firewalling. We don't have that luxury because I certainly don't have access to the firewalls here on campus. But what we would do is you'd say, all right, anybody connecting from that server, from that IP address, from that port is allowed to connect to this database server on this IP address on this port. And nobody else is allowed to send any network traffic at all to that server. By cutting it off at the network level, they can't even get to it. And so there's no need for a password. And you just control everything through the network level, which is much lower level than your application level up here, right? That's how you basically take care of two methods for taking care of passwords and connecting to a database in real life in a real application. The next the best practice is close your resources. Failure to close your resources wastes them, right? Even if you're going to use them again, right? Or even if you're not running out of connections, then you're still wasting processing time. You're wasting memory on both your computer and on the application computer and on the server computer, and you could eventually run out of connections. I think that you have 30 persistent connections. So once you open up 30 connections, and that includes connections from MySQL Workbench, there is a persistent connection being kept alive at MySQL Workbench so that I can execute these queries. I'll show you. Show process list. There. I, in fact, have 2 connections to the database. One of them is just sitting there idle. It's been idle for almost 10 minutes here. But the other one was the query that I just executed, the show process list. Right? If I did that 30 times without closing any of those connections, then the 31st connection that I try to open is going to throw an exception back at me. No, you can't do that. Right? Hope that you close all your connections, or if failure to do so once your application is done, it'll clean up after. Cross your fingers that happens automatically. But sometimes it doesn't. And sometimes you have to wait that 5 minutes for everything to time out and be reset. It can be very, very difficult to troubleshoot this. So make sure that anytime that you write code to open something, you immediately write code to close it and then go back and fill in the code in between. Because if you open up if you find out that you're running out of resources, you're running out of connections, it can be very, very difficult to troubleshoot that and find out where exactly in your code are you opening something that you never close. Right? In fact, that would require some sort of static analysis tool that goes beyond the scope of this course. Right? So make sure that you are closing them in the proper order and that you're closing them, period. Right? The next best practice is dealing with SQL exceptions. Again, unfortunately, most operations will throw that checked SQL exception, and we're forced to try and surround it with some sort of code, right? Everything that we do with the database is going to throw this SQL exception. All I'm doing now is catching and releasing, just like a good angler, right? That we're catching that and then rethrowing it as a runtime exception. Because of their short-sightedness 25 years ago, or whenever it was, when they thought that checked exceptions were a good idea. In the intervening 25 years, we found out that they're not a good idea, right? So just catch and release, rethrow it as a runtime exception. You may want to log it as an error before you rethrow it. If and when you do logging, you use a proper library. System.out and system.error are not proper logging libraries. Right? The solution is to use something like, say, log4j. I'm going to show that to you now. Right? So suppose that something happens. Suppose that I've got the wrong password here. Right? Normally, this is just going to end up with an SQL exception, right? But that's because the entire thing died. Now think about a real application that's running in a server. Just because one thing dies doesn't mean that it should bring down the whole server. One user has a problem doesn't mean that the other 100 users that are accessing that application right now should, be whatever they're trying to do should be killed, or the entire server goes down or something like that. So usually what you do is you throw this exception, and then everybody else goes along, on with the rest of their lives. But you do want some information about it. Right? For example, you want to say system.out.println something, a bad password for something. Right? That is not a proper logging system. That'll output to your console just like this one did. But in a real application, there's not somebody sitting there staring at the screen 24/7 waiting for some error message to pop up and then jump into action. Right? Instead, what you want is a proper logging system where all these events, errors, information, or anything else that you want to log is logged to a bunch of files. And then a proper logging system will give you a bunch of bells and whistles and features to use with those files. For example, each day, the logs for that day are collected into one file, and then at the end of the day, a brand new file is created, and logs are now on that one. And then this one is saved over here with a date time stamp automatically. Right? Or you could have it so that you don't want too big of files. So you could have it so that it's this file starts getting read, but when it hits 1 megabyte of information, it gets put off over here with a date time stamp, and a new one is started. And then you don't want too many files on the system, so you keep the last 30 days of records or something. And so the proper logging system will say, okay, today's a new day. Let's go ahead and delete the oldest day so that we only have 30 days of logs, right? This is an excellent system to use, but it is a lot of work to do it from scratch. And it is definitely not something that the standard output gives you. So what you want to do is you want to bring in a library to do it. The library that we're going to suggest that you use is log4j. Right? And when you go searching for it, make sure that you're searching for log4j2. Right? And that'll take you to Apache log4j2. You can go ahead and download it. This is just a jar file like usual. In fact, I already did it. Let me go ahead and open this up. There it is. Right? There are lots of jar files here, actually. The two that you want is the API and the core. Those are the only two that you need. Right? So let me go ahead and bring those over into my project over here. And I've got a lib folder, and I'll cut and paste, or not cut and paste, but drag and drop, copy those over. Great. Now I need to add them to my build path. This is exactly what you've done with all of your jar files up to this point. So build path, add to build path. And now I can start using this log4j system, right? So how do we go about doing it? I need to make sure that I'm looking at some code here, right? All right, so every class that you do should have and this is a database data loader class, so I'll go ahead and add a logger for that class. Because if you're going to log information in one class, you want to distinguish it from information in a different class. And so I'm going to create this logger here, log manager, get database loader. There we go. Just change it because it was a cut and paste. Let me go ahead and bring these in. This should be from log4j and log4j. There we go. Yep. All right. So now once we've got this logger, I'm just making it static because there should only be one logger for a class. If you had 1 million instances of this class, why do you have 1 million loggers, one for each one? Maybe that's something that you want to do, but that's not how it's usually done. Right? Instead, we have one logger for this class. Now I can actually use this and start logging some useful information. For example, load person by ID. What I can do is when I first initially come into this method, I can log some information, .info. Right? There we go. And I'll go ahead and say that I'm loading person with person ID equal to, and then concatenate that person ID there. Now that's going to that's going to log some information here that I'm loading up this person. Maybe that's useful, maybe it's not. If it's not, then you can go ahead and shut it off. Right? But you do so with the logging system and configure it, right? With a separate configuration file. Maybe down here we've got some more information. For example, instead of bad password or something, I'll go ahead and say logger.error, right? So different levels of logging here. In fact, there are several. There's the lowest one is debug, then trace, then info, then warning. It's just a warning, who cares? But then error is the highest level. And then what you can do is you can configure, I only care about debugging statements right now. Go ahead and not log everything else because I'm just testing something out. When we move it out to a full system, we don't care about those debugging statements. We just care about the highest priority ones, info, warnings, and errors, right? You get all of those free bells and whistles by using this system here, right? Bad password or something. And then you can also provide the stack trace by putting in the error here, okay? Do I have a bad password still? Okay, good, I do. Now let's come over to our data loader, demo class, sorry. Now, usually the way that you use this system is you have a separate configuration file, either a property file or an XML file that then you configure this and it takes care of everything automatically for you. The way that we've set up the grader, you don't have that luxury. So I'm going to show you how to take care of it by putting the following two values into your main here. So we're going to manually configure this, configurator, default configuration. You can configure it to do a lot of things. For example, the date-time formatting of the information. That you can configure what that looks like. I'm going to go ahead and set the root level here on the Java, that one. Make sure that they're all log4j if you're using log4j. And now what I'm going to do is I'm going to actually execute this. Let's execute some information here. I don't have a logger here, so never mind. I don't care about it. I'll just go ahead and execute this as is. And let's take a look at what it looks like. There we go. There's my log system. So the rest of this was just standard output. That was me printing things, right? So loading person with person ID 10. That was our loading of Grace Hopper there. Bad password or something, right? It's being labeled as an error. You can do a lot of stuff with this system. For example, you can set up rules that say, whenever an error occurs, go ahead and also email me at the same time, as well as putting something into the log system. You can say that, all right, don't log to a file, log to a database, so that I can use my SQL to search the logs for when was the last time this person logged in, right? I can get a complete list of, for example, what we do with the grader. We look at how many times you graded yourself, how many times you handed something in, right? And in Computer Science 1, we typically use those hand-in logs to trace, academic integrity violations. That they'd handed something in that didn't work, and it was far from working for right up until 10 minutes before the due date, and then miraculously that they went from 0 to 100% in the last 10 minutes. Something's fishy there. Let's go ahead and run Moss, right? And so we use logs to do stuff like that. In a real system, you would use logs for anything that you want to log and information that you need to trace. Right? Access denied, and then it shows up here as an error down here. All right. Let's go over to the database data loader, and let's go ahead and log some other information. For example, when we loaded up all the people, I guess that's a different file, data loader. Right? Nope. No, this is the file. Right. Loading up all the people, so logger.info, there we go, and not all this stuff, but loading up everyone, ... right? And then you can trace this throughout and be like, okay, looks like everything's good up to that point, done. Done loading everyone. Right. Let's go ahead and run this again and see those two lines. Loading up everyone, done loading everyone. You can actually trace how much time it took to do that operation. Right? In this case, it took what? 636, so 136 plus 41, 171 milliseconds. Right? Yeah, 170, so 0.17 seconds. And you can trace things and see how long it's taking. A whole bunch of stuff that you can do that's not possible if you just use system.out, system.error, right? A proper logging system is what you want to use. Right? Log4j is the one that we recommend. And doing so is worth bonus points in your next couple of phases here. So I've just shown you exactly how to do it. Just doing it is worth bonus now. Right? Let's see. Always use prepared statements. This is, I think, our last best practice here. So in general, strings can contain anything, including SQL code. So for example, let's say I come over here, and where was I looking for a question mark? Nope. Database data loader. Isn't there a load person by ID? There we go. There it is. So remember, I told you, if you ever find yourself using string concatenation instead of prepared statements, you're in any language, in any situation, you are doing something wrong. Why are you doing something wrong? Well, what if I didn't just, concatenate this number, but what if I pulled in a string from, say, a web form? So somebody is asked to type their name and their password or something like that. They can type whatever they want. They can include, also type, say, 5, semicolon, drop database cberg. There we go. Now, what's going to happen with this SQL if it's not set up properly? What does that look like? Let's take it over here and to MySQL Workbench. Right. So there's our first, when the string concatenation occurs, of course, those double quotes go away, and you've got something that looks like this. So we'll go ahead and execute that first one. There, nobody with that value is there. And now let's go ahead and execute that second one. I'm not going to do, well, I guess we could do it. Do I want to do it? What's going to happen to all of our data? Bye-bye. Right? Because we allowed somebody to come in and type whatever they wanted, and we use string concatenation. This is called an SQL injection attack. Right? And this is why we don't do it. Right? Because if you don't have your server configured correctly to not allow compound SQL statements like this, to not sanitize your statements and escape things, then you are opening yourself up to attacks from just a web form. Right? If you want to see this in action in in a lab, not this lab, but next week's lab, we actually show you how to do an SQL injection attack with the web app that you're building. And then we actually also have a cross-site scripting attack where basically you inject some SQL code so that the displayed HTML, all the albums are in this table. What happens is that the table then gets truncated, and then this message gets displayed of, please re-log in here by clicking this link. That link takes you to my website that then asks you for a password and or asks you for a login and a password. Don't do it. Obviously, I'm not going to do anything with it. But then it's all it's doing is harvesting passwords. And anybody stupid enough to fall for it, then I've got their password. Right? That's how cross-site scripting attacks and stuff like this work. That basically it makes it try to look like your bank account or your bank web address, but it's not. And so when you enter something in, somebody's sitting there watching. Okay, great. Now I've got a password. Now I'll go to the real website and break into their account there. Right? Don't do that because it's huge security issues. Only use prepared statements. Right? Do not be like little Bobby tables. I'll show you what I'm talking about here in a second. Right? Without sanitizing your code, you are susceptible to an SQL injection. We call it an injection. Why? Because they're taking some code and injecting it into your code. Right? It's kind of like a virus. It's not a computer virus, but it's a code injection into your code. A user may be able to execute arbitrary SQL code on your server and then do whatever they want with it. Usually they don't want to drop your database. Instead, what they're going to do is they're going to probe your system to try to see if they can get access to it, or if they can get it to give up information. They're going to steal passwords or something like that. They don't want you to know that they were ever there. Nobody is going to be, anybody who would delete data is just a vandal. People are out to steal the data. That's their motivation, and then to sell it to other people. Prepared statements in Java sanitize the inputs for you, ensuring that no SQL injection is possible. Everything gets escaped and taken care of. Never use anything else, right? It's just simpler to use one method to connect to a database. You might have a query that you never have anything that you concatenate to. So be it. Right? Still use a prepared statement. Why? Because sometimes you'll use an unprepared statement that doesn't do any sanitization. I don't know if that's a word or not. Sanitizes it, right? And then other times, okay, well, I'll use this because it needs to be sanitized. And then you screw up and you forget which one is which. Just be consistent about it. Always use a prepared statement. Right? Don't worry about it. You don't want to have to worry about it, because otherwise then you'll be like XKCD, little Bobby tables. Right, this is the classic XKCD, exploits of a mom. There we go. Hi, this is your son's school. We're having computer troubles. Oh dear, did he break something? In a way. Did you really name your son Robert? Then you end the quote there. Then you end the SQL statement, drop table students. Semicolon. Why are these two hyphens there? It's a comment. Whatever was out they're thinking ahead. They're thinking that you're using string concatenation, that you've got part of the query here, part of the query here, and here's where I'll inject everything. I want you to ignore all this stuff. So I'll inject a little comment here that ignores the rest of the statement. Right? And I will just simply drop your student table. Right? Also, really, really bad naming convention here. You do not pluralize tables. Right? So not only were they not protecting themselves against SQL injections, they also had really bad practices. Oh yes, little Bobby tables we call them. Well, we've lost all this year's students' records. I hope you're happy. Right? I hope that you've learned to sanitize your database inputs. Right? Not a year goes by without, I don't know if was anybody at Corn Hacks this year? I was not, but usually at least one team names their team name some SQL injection as a joke to see if entering of the team name actually results in an SQL injection attack. Programming contests, not at least one team uses an SQL injection attack name as their team name, right? Just to see, just as a joke, we know what an SQL injection is there, right? So that's what an SQL injection is. It's a way to inject SQL code onto the server. You never have to worry about that if you use prepared statements. Right? Even today in 2023, this is still the most common attack vector on web pages. Right? I don't know why. But you'd think that we'd have learned the lessons by now. It's usually PHP sites, though. Right? And PHP will never learn its lesson, or PHP users will never learn their lessons. Right? All right, so that takes us to the end of JDBC. Any questions? 10 minutes remaining? No? Well, you've got your database due this Friday. This basically takes us to the midpoint of the topics for this course. The rest of the semester, I mean, the bulk of your project, you have enough information to do like the next 2 phases. What we're going to do with the rest of the semester is get into the more theoretical part of the course, where we're going to start looking at algorithms and data structures. We'll start with list-based data structures. Right? We've been using lists up to this point, right? Without really thinking about it. There's a list. What kind of list is it? It's an array list. There's also this other kind of list called a linked list. How are they actually implemented, right? How does stuff actually work under the hood? And when would you want to use a linked list versus an array list? Right? Knowing that is the difference between just being a programmer and being a computer scientist or a computer engineer or an engineer. Right? In fact, one of the LAs in our weekly retrospective said that this course is great because it's the first time that it forces people to start thinking like an engineer instead of just a programmer. And that kind of reinforces this this quote that I have that I use in Computer Science 3, which is pure data structures and algorithms, that if you want to be a world-class programmer, you can program every day of your life for 10 years. Or what you can do is you can program every day of your life for 2 years and take an algorithms course. Because an algorithms or data structures course, but they really meant algorithms and data structures, because an algorithms and data structures course is worth 8 years of experience, 8 years of blunders, 8 years of screw-ups. Right? I will show you on Wednesday a motivating example of a linked list versus an array list, a linked list versus an array list, where that subtle difference can mean the difference between your program executing in a matter of seconds versus taking months, literal months, to execute, right? Just by using a different data structure because of the way they work. But to understand that the way that they work, we need to get under the hood and actually look at these implementations. So for the rest of the semester, it will be focused on data structures and algorithms, algorithm analysis. We'll get into trees and tree-based data structures. Most of it will still be relevant for your project, not directly, but definitely for the last phase where you have to design your own list data structure. And then certainly for the last assignment, which has nothing to do with your project, it's theoretical, theory-based written questions. Right? Otherwise, somebody did ask online, is there any exam for the final exam for this course? No, there's no exams for this course. It's all 100% project and assignment based and lab. Right? All right, then I'll see you for the second half on Wednesday.